So we are going to look at our last and fifth method to solve quadratic equations. So we've already been spending time graphing. We looked at taking the square root, which also is a variation of completing the square. We see that we can factor things. By the way, whenever we complete the square, we are factoring, right? So they're all linked there. But today we're going to look at something called quadratic formula. So from whence does it come? Where do we get this magic formula? So I'm going to walk step by step through this. So we are going to take our standard form here, and then we're going to go step by step. We're actually going to complete the square for this thing. So I'll admit it gets a little bit ugly, but our first step here is we're going to divide everything by a, which is primarily is very similar to the other method that we did. So I'm just going to take everything divided by a. 0 divided by a is still 0. I'm going to end up with an ugly little fraction right there, an ugly little fraction right there, 0 over there. Now, if you recall, we also have to isolate the constant. It's true we have lots of letters here, but only the x is the variable. The b and a are actual numbers. We just don't know what they are. C and a are actual numbers. So, to isolate the constant, I have to subtract c over a from both sides. So I did that. Now we have a little funny thing where I have to complete the square by taking this coefficient here. Before we said take the b, right? But the number in the front is the b, not the letter on top. The whole thing here, the b over a, is the thing we have to add to both sides. So remember what we do? We have to take that, divide it by 2, and remember, dividing by 2 is the same as multiplying the bottom by 2, and we have to square the whole thing. So that's my missing term. Yep. Now I'm going to take that, and I'm going to add it to both sides. Add it to both sides. So over here, I'm going to add b squared over 4ac. Wait a tick, that's not what you wrote. When you square the b, and when you square the denominator, you get b squared over 4ac. So I'm going to write that on both sides.
4a squared because...
Oh, sorry, 4a squared, thank you. 4ac comes up in the formula in a little bit. You'll see it. Okay, now we have completed the square. I just need to factor the left side. You can take my word for it, but this is what happens when you factor it. Because the red term here, square rooted, is b over 2a. Now on the left side, excuse me, the right side, I'm going to move some stuff around. And if I multiply that by 4a, so that I can have a common denominator, so take my word again for it here, is I get b squared minus 4 times a times c, all divided by 4a squared. Next step is to take the square root of both sides. So when I do that over here, the radical will kill the square. And I'm actually, just to simplify it, I'm going to take the square root of the top and the bottom. I'm just going to split it just to show you that it does happen. Because it turns out the denominator here is a perfect square. So x plus b over 2a equals plus or minus radical b squared minus 4ac. The radical goes all the way to the c. And everything so far is going to be over 2a. So what is pretty much my last step? What do I have to get rid of on the left side?
2a.
The b over 2a. So when I subtract that, and I left room right here, this is what it's going to look like. Negative b plus or minus radical b squared minus 4ac all over, make sure the whole thing is over 2a. When I say whole thing, the whole side, all the way to the negative b. Don't put the x over 2a. And this, my friends, is the quadratic formula. So let me sing it for you, because life would not be complete without the song. X equals negative b plus or minus radical b squared minus 4ac all over 2a. Yay! Or think of it as a story. And this is the story right here. Once upon a time, there was a negative boy who could not decide whether or not to go to a radical party where there would be square dancing with 4 awesome chicks. And it would all be over at 2 a.m. Now that we know what the quadratic formula is, let's use it. So the key is to make sure that we have our form in standard form. So the equation has to be in standard form. Again, how do we know it's standard form? Because we have an A, a B, and a C. So in this case, I just recognize that my A is 1, my B is 9, and my C is 14. Now let's recollect. Our quadratic formula is x equals negative b plus or minus radical b squared minus 4ac all over 2a. So what we're going to do is substitute our a, b, and c into the various positions. So x equals negative 9 plus or minus 9 squared minus 4 times a times c all over 2a. Now we can begin to simplify, and what's nice about this is every single time the same 4 products will be simplified at the exact same step. So x equals negative 9 plus or minus radical 81 minus 56, radical all around that, all over 2. Now from here, I am going to simplify further, so negative 9 plus or minus radical 25 over 2. And now continuing to simplify, and what's nice here is that this actually can split into 2 separate problems. Why? Because the radical 25 is a perfect square, or is an integer there. So when I split, things are going to work out pretty nicely. On the top here, we get negative 4 divided by 2, so we get negative 2. On the bottom down here, we get negative 14 divided by 2, so we get negative 7. So my 2 solutions, x is negative 2 and negative 7. The next thing we're going to do is look at another situation, except it's not going to be as clean. So our first step in this one is to actually rewrite it into standard form. So I subtracted the 9x from both sides, and now I identify what my a, my b, and my c are. A is positive 4, b is negative 9, and c is 3. Now to save some time, I'm going to go ahead and substitute as I go. X equals negative 9, which is my b, plus or minus radical negative 9 squared minus 4 times 4, which is my a, times c, which is 3, all divided by 2 times 4. Now we are going to simplify the same 4. So 9 up front here, 81 here, minus 48 there, and 8 in the denominator. 9 plus or minus 33, and that's a radical, all over 8. And we actually have an answer. Now, this is the exact answers. There are 2 solutions. However, it does ask us to round our answers to the nearest hundredths if necessary. So when we plug those into a calculator, we're going to end up with 2 solutions. And we get 1.84 and 0.41. So those are my 2 solutions, and these things are estimates, and these are my exact solutions. All right, now with that in mind, we will have you practice some more, and then next time we're together, we will see an application and then look at what's called the discriminant.